Testing two populations is probably the most common, but unfortunately the world is not that simple, and quite often we do need to compare three or more populations, and so we need appropriate techniques to do that. So now if we consider that we don't have just two populations, but actually k of them, and each of them may have its own number of observations and of course its own sample size. So in this case, we may want to consider or make inferences about the differences between the mean values in those different populations. So for instance, an example problem here, if we consider atherosclerosis, or in other words, hardening of the arteries, it's a major cause of death in much of the developed world. And it progresses by accumulation of plaque on the interior wall of arteries, which obstructs the blood flow. So the more plaque in here on the sides, the harder it is for the blood to flow, and of course that causes some risks. So this level of blockage in the artery is called stenosis, and we calculate it as the difference between 1 and the ratio of what is the width of this blocked artery and what should be the ideal width here. So now a mechanical engineer performs an experiment to investigate the collapsibility of arteries due to the presence of stenosis. So the engineer considers three levels of stenosis. There is 0.78, 0.71 and 0.65. And at each stenosis level, the engineer pumps a blood-like liquid through the model artery and measures the flow rate at which the model collapses. So he gets three sample means from those tests. And we could look at the data in more detail. So now we have test 1 in here, where we have different measurements. So that's one sample. Then we have the second case of stenosis, its own sample, and the third one. And we would like to conclude how different these ones are, or are they different at all. And then we have this overall mean of the entire set of observations for the three different levels. So consequently, the data suggests that the average flow rate at collapse decreases as the amount of stenosis increases. But is it statistically significant result? So this question can be examined by testing the null hypothesis of equality of the mean values. And then if we were to reject the null hypothesis, that would allow the engineer to conclude that the average flow rate at collapse does depend upon the level of stenosis. And this type of testing is called one-way ANOVA. So we will look into more detail in the next video.